Good evening, students. My name is Abdul Bari. I welcome you all on behalf of ACE Academy. We are taking the questions, PYQs and example questions for RRB JE CBT-II for the subject of Fluid Mechanics 1. Let us get started. The first question over here, you can see. You see, majority of the questions will come from the topic of properties of fluids. Okay. The first question we are having over here is, an ideal fluid is defined as a fluid. He has given you 4 options over here, you can see. An ideal fluid is a fluid which is option A compressible, option B incompressible, option C incompressible and non-viscous, which is also called as inviscid, option D it has negligible surface tension. You see, ideal fluid basically is coming from the concept of viscosity only. Any fluid whose viscosity primarily is equal to 0 is known as ideal fluid. This is a primary property of ideal fluid. Okay. Other names for ideal fluid is inviscid fluid. It is also sometimes called as frictionless fluid. One more name is frictionless fluid also. Okay. Apart from mu being equal to 0, it is supposed to be incompressible. If it is incompressible, density is supposed to be equal to constant. Apart from this, it is supposed to be having bulk modulus tending to infinity, compressibility equal to 0. All these are properties. Even surface tension is equal to 0. All these are properties of ideal fluid. Now, which option do you think is the best option over here? The primary property is non-viscous. Apart from being non-viscous, it is also incompressible. Therefore, the best answer over here is option C. Option C over here would be the correct answer. Very good. Moving further to the next question. The next question over here is, Newton's law of viscosity states that. Now, what is Newton's law of viscosity stating? We know Newton's law of viscosity states tau is equal to mu into du by dy. This is the actual equation of Newton's law of viscosity. Tau is equal to mu into du by dy. Mu over here is viscosity, du by dy over here is rate of shear strain, tau over here is shear stress. I'll step aside and you can see the options. Option A says shear stress is directly proportional to velocity. This is wrong. You see, it is not having a relationship between shear stress and velocity. Next, shear stress is directly proportional to velocity gradient. It is correct. Du by dy is also called as velocity gradient. C is shear stress is directly proportional to shear strain. Now, please be careful. Shear strain would be wrong, but rate of shear strain would be correct. Rate of shear strain would be correct because du by dy is also called as a rate of shear strain. Now, next thing, shear stress is directly proportional to viscosity. This is also correct. But you have to be careful. This is a very good question. You have to be careful over here. Which option over here is a better option? There are 2 answers correct over here. Shear stress proportional to gradient, shear stress proportional to viscosity, both are correct. But if you recall, in reality, Newton's law of viscosity starts from tau proportional to du by dy. And you remove proportionality sign and say tau is equal to mu into du by dy. So, the primary condition for Newton's law of viscosity is tau proportional to du by dy. Therefore, the correct answer over here is option B. Option B happens to be the correct answer over here. Okay. Option B is a correct answer over here. Moving further. Let us say kinematic viscosity is defined as. What is the definition of kinematic viscosity? He is saying kinematic viscosity over here is nu, and the value of nu is equal to mu divided by rho. Nu is equal to mu divided by rho. You can look at the options now. The options over here is dynamic viscosity times density. This is wrong. Dynamic viscosity times pressure is also wrong. Dynamic viscosity by density is correct. So, option, one second, they have misplaced the points over here. Let us say this is B and this over here is C. So, correct answer over here is option C. Option C is correct. Moving further. Dynamic viscosity has a dimensions of. You see, units and dimensions are some of the most important topics in examination. Okay, any examination you take, units and dimensions will be very, very important. Let us discuss over here the units and dimensions of both kinematic as well as dynamic viscosity. Let us start with dynamic viscosity. Dynamic viscosity, it has the units of Pascal second or Newton second per meter square, also equal to kg per meter second. These are the units of your dynamic viscosity. All these are SI units: Pascal second, Newton second per meter square, kg per meter second. If you dimension this, the dimension over here is m L power minus 1 T power minus 1. Okay. M L power minus 1 T power minus 1, this was supposed to be the option, M L power minus 1 T power minus 1. That way answer B over here would be correct. Okay. Anyway, let us discuss further regarding the units and dimensions. These are the SI units. The CGS unit for this thing, the CGS unit of this thing is going to be gram per centimeter second. This is also called as 1 poise. And the value of 1 poise is equal to how much? It is equal to 0.1 Pascal second. Very quickly, let us talk about kinematic viscosity. Kinematic viscosity is basically dynamic viscosity by density. It is going to have the SI units of meter square per second. Therefore, the dimensions over here is m power 0, L power 2, T power minus 1. Okay. The CGS unit over here, is centimeter square per second, and this is called as 1 stoke. This is known as 1 stoke. The value of 1 stoke is equal to 10 power minus 4 meter square per second. Okay. Remember these things. I am pretty sure there is going to be a question coming from these things in your examination. These are some of the very, very favorite topics to ask questions from in your examinations. Moving further to the next question. Look at this question over here. Surface tension has what units? Now recall, surface tension has two formulas basically. Surface tension is surface energy per surface area. This is one formula for surface tension. Surface energy per surface area basically means what? Energy has the units of joule, area has a unit of meter square. Joule is also equal to Newton meter divided by meter square. Therefore, it has also a unit of Newton per meter. Okay. Another formula for surface tension is what? It is surface tension force upon circumferential length. So it is force upon length, which is again Newton per meter. Okay, very, very simple thing. You can look at the options. Force per unit area would be wrong. Of course, energy per area would be correct over here. Force per unit length is correct. Force per volume is wrong. The correct answer over here is option B. I'm assuming all of you are getting these answers. Okay. Moving further to the next question. Compressibility is equal to how much? देखिए, when it comes to compression, there are two properties important for you. One is compressibility itself, the other is called as bulk modulus. You have to keep both these things in mind. As a matter of fact, remembering one value is as good as you can remember the second value also, because both are inverse of each other. Now, compressibility alpha is basically the ability of a matter to compress. So, how easily it is going to compress? How easily it is going to compress is given by volumetric strain dV upon V upon dP. But over here, we are going to make a small change, since we know that if you increase the pressure, volume will decrease. Therefore, dP and dV both are having opposite signs. If they both have opposite signs, this property with this value will have a negative value. Therefore, we multiply with a negative so as to make a negative positive. So we can say the formula is minus of dV by V upon dP. You can observe over here, the correct answer over here is option A. It is giving you minus of dV by V upon dP. Achha, one more thing. What if we take inverse of compressibility? If I take 1 by alpha, it is equal to what? Bulk modulus. So bulk modulus is equal to how much? It is equal to minus a dP upon dV by V. Achha, there is one more formula for compressibility. You should be knowing this thing. The rate of change of volume is also going to give you change of density. So d rho by rho upon dP. Only difference over here is you won't have a minus over here, because if volume is decreasing, density will increase. That is the logic basically. Okay. I hope this is clear to all of you. Moving further. Now we are coming to hydrostatic law. Hydrostatic law of pressure is given by what? What is hydrostatic law saying? He is saying. Okay. Now the value of hydrostatic law is basically, it is talking about dP by dH. dP by dH. It talks about rate of change of pressure with respect to vertical axis. dP by dH is equal to how much? It is equal to rho g. It is equal to rho g, or it is equal to gamma. It basically states that whenever you are having a static fluid, the pressure varies linearly, or not linearly, sorry, the rate of change of pressure with respect to depth is equal to specific weight of the fluid. It is equal to specific weight of the fluid. You can also write dP by dz, dP by dz over here. Only thing is, it is supposed to be equal to minus rho g or minus gamma. Okay. Now if you see over here, we do not have minus rho g or minus gamma, so therefore we will take plus rho g only over here. So dou p by dou z is equal to rho g. Option A is correct over here. I hope all these are clear to all of you. Moving further to the next question. Okay. Now this is one more topic from where every examination in India, even your RRB JE examinations, have asked questions. Okay. The question over here is the relationship between surface tension and difference of pressure between inside and outside of a liquid droplet is equal to how much? So delta P basically is equal to how much he is asking. What is the value of delta P? You see, whenever you are having a curved liquid surface, that time there is going to be a difference in pressure. Okay. The value of delta P, actual formula is sigma into 1 by R1 plus 1 by R2. This is the actual formula. But I would want you to memorize 3 results over here, 3 standard results I would want you to memorize. The 3 standard results: A bit, drop of liquid, B bit, gas bubble, and C bit. Also, one second, not gas bubble, rather liquid bubble. Liquid bubble, and C bit, jet of a liquid. Please remember these values. These are very, very important values. Directly they can ask you questions from here. In the case of drop of liquid, this becomes 4 sigma by d, where d is a diameter. In the case of liquid bubble, you are having 2 layers, just like a soap bubble. So in the case of soap bubble or liquid bubble, it is going to be 2 layers, therefore 2 times the value of the previous question. So 8 sigma by d. In the case of jet of liquid, it is going to be equal to 2 sigma by d. Please remember these values, extremely, extremely important values for you. You can expect a direct question from any of these 3 cases. Now if you see, he is asking in the case of a liquid droplet, it is equal to how much? It is equal to 4 sigma by d. So we can see over here option C would be correct. 4 sigma by d is given by option C. I hope this is clear to all of you. The standard formula actually is this particular formula. Okay, this is a standard formula we are having. Fine. Okay. Moving further to the next one. Acha, I'm having one more PYQ which is having soap bubble now. Okay, one more PYQ with soap bubble. Come on, you can answer me this thing. For a soap bubble, the surface tension is sigma and the difference of pressure delta P is related by what formula? Just now I have mentioned it is equal to, in the case of soap bubble, 8 sigma by D. Delta P is equal to 8 sigma by D. I hope these are all clear to all of you. Moving further. The capillary rise or fall of a liquid in a tube is given by. What is the formula for capillary rise or capillary fall? Okay, we'll answer this question. We'll also address some questions which they can ask you from here. The formula for capillary rise, in the case of a tube is given by H is equal to 4 sigma cos of phi or theta they can say, which is contact angle, divided by gamma times D or rho G times D. This is a formula we are having for capillary rise in a tube, 4 sigma cos phi upon gamma times D or rho G times D. If you observe over here, we are having this particular formula. I have written phi over here, they have used theta, same thing, don't worry. So the answer over here is B. Now some things which they can ask you questions from here is, how is H going to vary with respect to diameter? Remember, H is always inversely proportional to diameter. H is always inversely proportional to diameter. They can create a question, I have seen in many papers such questions, where they say you are having two tubes, diameter 1 upon diameter 2 is equal to 1 by 2. If the value of H1 is equal to 10 mm, the value of H2 is equal to how much? H2 is equal to how much? How will you answer this thing? You will write H2 upon H1. Since inverse proportionality is there, it is equal to how much? D1 by D2. H2 upon H1 is equal to D1 by D2. Okay, now you can solve for this thing, you will get the value of H2 is equal to 5 mm. Likewise, that is one category of question they can ask you. This is one category of question. One more thing regarding the value of contact angle phi or theta. Remember this thing, there are two possible cases. One case is capillary rise. When will capillary rise take place? Whenever cohesion is greater than adhesion, capillary rise will take place and the value of theta or phi will be less than 90 degrees. This is capillary rise. If cohesion is weaker than adhesion, all these are previous questions only, whatever I am discussing, then the value of phi becomes greater than 90 degrees. In this case, what happens? The cos of phi will become negative, H will become negative, capillary depression will take place. I hope this is clear to all of you. Let us move further now. Pascal's law states that pressure at a point is equal in all directions. When a liquid is at rest, a fluid is at rest, laminar flow, turbulent flow. Strictly speaking, none of these is correct answer, but still amongst these options, the best answer over here is fluid is at rest. Then what is the correct answer? I have taken this question to show you that sometimes you might not get a perfect answer, but you have to choose the best answer amongst all the present answers. Okay. Actual answer is Pascal's law is valid whenever the shear stress in the fluid is equal to 0. This is a perfect answer. In this, there is one particular case when the fluid is at rest. Fluid is at rest. There is one more case when the fluid is not at rest, then also tau can be 0, that is called as rigid body motion. That is called as rigid body motion. Rigid body motion. So it is possible that Pascal's law is valid in the case of motion also, but only thing is that kind of motion is called as rigid body motion. Now what I am seeing, I am not seeing any option of tau equal to 0 over here. Therefore, the next best answer I am taking, which is telling me what? Fluid is at what condition? Fluid is at rest. Are you following this thing? I am taking the next possible best answer, which is fluid is at rest. Okay. 1 minute please. there is some issue with the video. I'll come back within 2 minutes. Please be patient. Please hang on. Within 2 minutes, I'll be coming back. Thank you. Let us continue. I'm sorry for the disturbance. Let us continue. Look at this question. The gauge pressure at a point. Again, a very commonly asked question. Almost every examination is asked this question. Gauge pressure is equal to how much? We are having a formula that the value of P absolute is equal to how much? It is equal to P naught plus P gauge. That means the value of P gauge is equal to how much? It is equal to P absolute minus P naught. It is P absolute minus P naught. So it is absolute pressure minus atmospheric pressure. So absolute pressure minus atmospheric pressure. Option B is the correct answer over here. Remember one more thing. Negative gauge pressure is called as vacuum pressure or suction pressure. Okay? It might be also a question in your examination. Moving further. Atmospheric pressure head in terms of water column is equal to how much? You see, atmospheric pressure, standard atmospheric pressure is equal to 1 atm. The value of 1 atm is equal to 101.3. It is equal to 101. It is equal to 101.3 kilopascal. It is approximately equal to 10.3 meter of water. Approximately 10.3 meter of water. Also approximately 760 mm of mercury. All these are very standard values you are supposed to remember. Now since he has asked in terms of water column, the correct answer over here is option D, 10.3 meter of water column. Moving further. The hydrostatic pressure on a plane surface is equal to, whenever they use the word hydrostatic, strictly speaking, the word should be force over here, or if they are using the word pressure, they are supposed to use a word total pressure over here. Okay, you can use the word hydrostatic total pressure, or you may use the word hydrostatic force on a plane surface is equal to. The formula for hydrostatic force is equal to how much? It is equal to gamma into area times h bar. This is the formula we are having for hydrostatic force. Gamma is rho g, area is area, h bar is h bar. ठीक है. The resultant hydrostatic force acts through a point which is known as. Now remember, whenever you are having, let us say, a free surface, you are having a particular plate. Now on this particular plate, suppose this is the centroid of the plate or center of gravity of the plate. Somewhere below this, there is going to be a certain point. This point over here is known as center of pressure. On this center of pressure, you are going to have the hydrostatic force concentrated. Okay, this is called as center of pressure. So the correct word over here is option C, which is center of pressure. The resultant hydrostatic force acts through a point known as center of pressure. And remember, this is going to be perpendicular over here. Next thing, for submerged curved surface, the vertical component of hydrostatic force is equal to how much? Now in the case of curved surfaces, there are two components of hydrostatic force. One component is horizontal component, one component is vertical component. Horizontal component is equal to how much? It is equal to gamma into area h bar of projected area. When you project the curved surface area on a vertical plane, then you get some projected area. So gamma area h bar of projected area. Vertical component is equal to weight equivalent thrust. It is equal to weight equivalent force. So therefore it is equal to how much? It is equal to gamma times volume. How much weight equivalent force? It is equal to weight equivalent force of the volume starting from zero pressure line or starting from the interface up till the curved surface. Now let us look at the options over here. Mass of the liquid, that is wrong. Weight of the liquid, that is correct. Next thing, force of the projected area of the curved surface, this is for horizontal component. So the correct answer over here is option B. Option B would be the correct answer over here. I am stepping aside so you can look at the options once. Moving further. Differential manometers are used for what purpose? You see, manometer is used for measuring pressure, that is fine. But differential manometer is not used specifically for measuring pressure. It is used for measuring difference in pressure between 2 points. So the correct answer over here is option C, difference in pressure between 2 points. Next. A submerged body will be in stable equilibrium if, you see, there are two types of bodies. Let us recall, one is a floating body, one is a submerged body. When it comes to submerged body, you see, for it to be in stable condition, what is supposed to happen? Its center of gravity is supposed to be, below the center of buoyancy. Okay, these are called as bottom heavy bodies. And bottom heavy bodies are having low potential energy, therefore high stability. Okay, remember, low potential energy, high stability. So you see, option A, center of buoyancy is below center of gravity, perfectly wrong. Center of buoyancy coincides with G, that is a case of neutral equilibrium, that is also wrong. Center of buoyancy is above the meta-center. Meta-center is not a concept at all in the case of submerged body. Center of buoyancy is above center of gravity, that is perfectly correct. So the correct answer over here is option D. Remember, the word meta-center is useful for which case? It is useful in the case of floating bodies. It is useful in the case of floating bodies. Remember this thing. Moving further. अब देखिए, he is asking a question on floating body now. For a floating body, if the center of buoyancy is above the center of gravity, the equilibrium is. center of buoyancy is above the center of gravity. You see, you are having some floating body, let us say, in the case of floating body. You see, whenever it comes to floating body, we have to talk about metacenter. He's not talking about metacenter, he's talking about center of buoyancy, center of gravity. The answer is, using these two, we can't answer the question. For us to answer this question, the condition is Gm is supposed to be greater than 0, then we can say stable. That means your metacenter should be above, center of gravity should be below, then it is stable. But right now he is only speaking about center of gravity and center of buoyancy. Therefore, the correct answer over here is none of these. We can't answer this question at all, whether stable, unstable or neutral. Okay. Moving further, the metacentric height experimentally is given by, what is the formula for metacentric height experimentally? Let me recall the formula. The formula for metacentric height experimentally is Gm is equal, there are two formulas basically for metacentric height. Let us talk about both the formulas very quickly. One formula for metacentric height is I by V minus Bg. This is one formula for metacentric height. I is minimum area moment of inertia, V is volume of fluid, Bg over here is a distance from center of buoyancy to center of gravity. Another formula for Gm, which is identified using the experiment, it is P times X upon W times tan theta. W is weight of ship, P is weight of a load, X is a distance from by which you are displacing the load. So you see, this over here, he has used small w in place of P, capital W in place of weight of the ship or floating body, theta is the angle of tilt. So now according to our formula, it is W times X, P times X, W times X. This answer is option C according to our formula. So remember, there are two formulas over here. One formula is I by V minus Bg, one formula is P times X upon W times tan theta. One more question. Do you remember, whenever you are having a stable equilibrium floating body, it is going to experience simple harmonic motion. It will have some time period of oscillation. He is asking a question regarding the time period of oscillation. The time period of oscillation is given by how much? The formula for time period of oscillation is given by time period is equal to 2 pi root over of k square upon g times gm. 2 pi root over of k square upon g times gm. The correct answer over here is option B. One more question they can ask you from here is, how is time period going to vary with respect to gm? Remember, time period is inversely proportional to root over of gm. More the metacentric height, less the time period, faster the oscillations. So high stability, remember this thing, high stability implies low comfort. High stability implies low comfort. Remember this rule. Moving further to the next question. Now we are entering into Bernoulli equation concept. Bernoulli equation is derived by making what assumption? Assumptions of Bernoulli equation probably is the most important question throughout Bernoulli equation chapter. In Bernoulli equation chapter, nothing is more important than assumptions. Please remember this thing. Starting from gate examination to any examination in India you write, whether RRB, SSC, JE, whatever examination you write in India, they will ask you, IES examination, whatever examination, they will ask you Bernoulli equation assumption. As a matter of fact, recently concluded gate examination, which was 2 months back actually, not very recent also, still over there also they asked regarding the assumptions in Bernoulli equation. What are the assumptions in Bernoulli equation? First thing, the flow, remember, it is steady, it is incompressible, it is inviscid or frictionless, non-viscous, it is irrotational, it is irrotational, it is along streamline, along streamline. These are the assumptions in Bernoulli equation. If you don't remember, please memorize from here itself. Steady, inviscid, incompressible, irrotational and along a streamline. These are the assumptions in Bernoulli equation. Now if you see over here, uniformity is never an assumption in Bernoulli equation. Uniformity is never an assumption in Bernoulli equation, because if the flow is uniform, then the velocity everywhere should be same. If velocity everywhere is same, why are we even writing velocity head? Why don't we cancel off velocity head? Because if it is same, we can cancel it off. So uniformity is never a criteria. If you see over here, steady is there, non-viscous, inviscid is there, incompressible is there, irrotational is there. So answer C over here is correct. Answer C is correct over here. Okay? Very, very important question. Next thing. The flow rate through a circular pipe is measured by, okay. Flow rate means what? Discharge. Flow rate over here means discharge. What is the device used for measuring discharge? Pitot tube is used for measuring velocity. Orifice meter and venturi meter both are used for measuring discharge. None of these is wrong answer. Now, if he has given both these things, okay, you can choose any one of them, but the better answer over here would be a venturi meter. Moving further. If the velocity, pressure and density change at a point with respect to time, the flow is called as, please understand, change at a point with respect to time. Okay, whenever changes are taking place with respect to time, we talk about steadiness and unsteadiness. So if it is changing, we call it as unsteady flow. Okay, if it is not changing, we call it as steady flow. Answer is unsteady flow. Next thing. The convective acceleration in x-axis is given by how much? Now what is the formula for acceleration? Let me write down acceleration AX formula. It is equal to dou u by dou t plus u into dou u by dou x plus v into dou u by dou y plus w into dou u by dou z. This is the acceleration formula we are having. Now in this acceleration formula, if you see, there is one term present over here. This is called as local acceleration. This is called as local acceleration. Then you are having the combination of these three terms over here. These three terms together is known as convective acceleration. This is known as convective acceleration. So since he is asking you regarding convective acceleration, what is the correct answer over here? If you observe, the correct answer over here is option D. Option D is the correct answer over here. Moving further, the fluid particles move in a zigzag way, the flow is called as. Imagine a particular flow in which a particle is moving wherever it wants. Some random motion is there. Likewise, every particle is randomly moving. We call such a flow as turbulent flow. Turbulent flow is the opposite of laminar flow. In the case of laminar flow, what happens? The particle in a particular layer will always be in a layer. Therefore, it will move along streamlines. This is laminar flow. And zigzag way, it is which flow? Turbulent flow. So the answer over here is option C. Fluid particles move in a zigzag way, it is turbulent flow. Moving further, the density of a fluid is constant from point to point in a flow region, it is called as what flow? Density is constant. If density is constant, that means the fluid is not getting compressed at all. If it is not getting compressed at all, we can call it as incompressible flow. The flow has become incompressible flow. Next thing. If the velocity, pressure and density do not change with respect to time at a point, do not change with respect to time at a point. The word do not is important. If they are not changing with respect to time, we call it as what? Steady flow. And if it is, see, changes with respect to space will give you uniform or non-uniform. Changes with respect to time will give you steady or unsteady. Moving further, a flow is said to be laminar. When is a flow said to be laminar? You can have just now mentioned that thing. You can look at the options and decide. Option A is saying the fluid particles move in a zigzag way. That was turbulent flow. Option B is saying Reynolds number is high. That is also a case of turbulent flow. Option C is saying fluid particles move in layer parallel to the boundary. Now you see, this moving layers parallel to the boundary is a better answer over here. And remember, in laminar flow, Reynolds number is going to be less. Reynolds number is going to be less in the case of laminar flow. Viscous effects will dominate, therefore Reynolds number will be less. Moving further, look at this question, very commonly asked question in almost every examination. The question is saying for the laminar flow through a circular pipe, what is the value of maximum velocity in terms of average velocity? You see, very standard result is there. The value of u maximum is equal to how much? 2 times average velocity of flow. So the correct answer over here is option B, 2 times average velocity of the flow. At this point also, let me tell you regarding two constants. One is called as kinetic energy correction factor, one is called as momentum flux correction factor. Again, very important values in the case of laminar flow through pipes. Many examinations have asked questions from here. There is a possibility your examination also in future may ask a question from here. The formula of kinetic energy, the value of kinetic energy correction factor in laminar flow, it is given by 2. It is exactly equal to how much? 2. And the value of beta is equal to 4 by 3, which comes out to be equal to 1.33. 1.33. This is the value of beta. This is in the case of laminar flow through pipes. आगे बढ़ते हैं. Let us move further now. The loss in pressure head for a laminar flow in through pipe is varying according to, very important. Again, these are all very commonly asked questions. Loss in pressure head is basically head loss. Now it is possible you may not remember the value of head loss. Okay. If you don't remember directly the formula for head loss, remember Darcy equation, FLV square by 2GD. And in laminar flow, the value of F is equal to 64 by RE. 64 by RE is equal to 64 mu by rho Vd. 64 mu by rho Vd. Now let us do one thing. Let us put that value over here. So the value of head loss is equal to how much? It is equal to 64 mu by rho Vd multiplied to LV square by 2GD. If you simplify this, the value of head loss comes out to be equal to 32 mu VL by gamma times D square. This is the equation you are going to get for the head loss in the case of laminar flow. Now it varies according to, he is saying square of velocity, that is wrong, it is velocity power 1. Directly proportional to velocity, it is correct. Inversely proportional to velocity is wrong. So the correct answer over here is option B. Okay. Try to remember the formula at least of Darcy equation and friction factor in the case of laminar flow. This is friction factor, mind you, friction factor, not coefficient of friction. Next thing, for laminar flow through pipe, the shear stress over a cross section is, now let us talk about both the things, velocity profile as well as shear stress. Velocity profile is parabolic in the case of laminar flow, shear stress is linear in the case of laminar flow. Velocity profile parabolic, shear stress linear. At the center, shear stress is 0 because velocity is maximum. At the wall, shear stress is maximum. So I can say varies directly as a distance from the center of the pipe. This is correct. From the surface of the pipe basically means what? Surface of the pipe means it should be 0 at the boundary, maximum at the center. This is wrong. It is varying directly with respect to radius. Radius means distance from the center, because the formula for tau is equal to how much? If you remember, it is minus dp by dx multiplied to how much? R by 2. So the correct answer over here is option C. Option C is the correct answer over here. Good question, because B and C are looking similar, but the correct answer is option C over here. For a viscous flow between two parallel plates, the pressure drop is equal to. Now parallel plates is not a concept, you can skip this thing. Let us come to this question. Now the coefficient of friction, please be careful over here regarding friction factor and coefficient of friction. Please be very careful over here. Now, whenever the word friction coefficient comes in laminar flow, this friction coefficient, I use F prime, but books may use F also. The value of this F prime is equal to how much? It is equal to 16 divided by Re. Now, friction factor, which is equal to F is equal to 4 times F prime. This is equal to how much? It is equal to 64 by Re. 64 by Re. Now, you see, he is asking you not regarding friction factor, he is rather asking you regarding friction coefficient. So, since he is asking you regarding friction coefficient, the answer over here is 16 upon Reynolds number. Okay. Next question. The loss of head due to sudden expansion, try this question. Loss of head due to sudden expansion in a pipe flow is given by how much? Now, in the case of sudden expansion, the formula for head loss, direct formula based question, head loss is equal to velocity before eddy, which is V1, minus velocity after eddy. Please be careful, people do mistakes over here. It is not individual square, it is whole square divided by 2g. As a matter of fact, he has given you individual squares also over here, but it is whole square by 2g. So, the answer is option C, V1 minus V2 whole square divided by 2g. The head loss due to sudden contraction is equal to how much? Head loss due to sudden contraction is equal to, it is equal to velocity before eddy is velocity at vena contracta minus velocity 2 whole square by 2g. This is the actual formula, but this formula reduces to V2 square by 2g multiplied to 1 by cc minus 1 whole square. So, V2 square by 2g, V2 square by 2g should be there, multiplied to 1 by cc minus 1 whole square. That way option A is correct. If square is not there, you can choose none of the above. Acha. Next thing, hydraulic gradient line HGL represents what? HGL, hydraulic gradient line, is basically representative of piezometric head, that is P star by gamma, which is equal to pressure head plus datum head. Pressure head plus datum head. So, we can write over here pressure head and datum head, option D is correct over here. Next thing, energy gradient line represents, energy gradient line is basically P by gamma, total head basically, V square by 2g plus Z. All these things are coming. So, it is equal to pressure head plus velocity head plus datum head. Therefore, it is going to be option D, which is pressure head, velocity head plus datum head, all of them combined. Moving further, when pipes are connected in series, come on, try this question. Series and parallel, very famous concept. When pipes are connected in series, the total rate of flow is equal to how much? You see, in the case of series connection, you are supposed to remember Q is going to be constant in every pipe and head loss is added up. Head loss is added up. Okay. Coming to parallel connection, exactly opposite. Parallel connection, Q is added and head loss is same. Head loss is same. So, you can see over here, when pipes are connected in series, the total rate of flow is same as flowing through each pipe. Best answer over here, option C, it is same as flowing through each and every pipe over here. Okay. Moving further, power transmission through a pipe. In the case of power transmission through a pipe, the maximum power is observed. When do we have maximum power? Remember this thing, for maximum power, efficiency is supposed to be equal to 66.67%. In other words, the value of head loss is equal to 1/3 of gross head. You should have 33% losses. Then you are going to get maximum actual power. So, head loss due to friction is 1/3 of the total head at the inlet of the pipe. So, the answer is option D over here. Answer is option D. Now this is a question coming from the concept of water hammer effect. The valve closure is said to be gradual if the time required to close the valve, that is actual time of closure, is how much? Over here let us define two times of closure. One is critical time of closure. It is equal to how much? It is equal to 2L upon C. One is actual time of closure. This is actual time taken to close the valve. Actual time taken to close the valve. Now when we say it is gradual closure, you are taking lot of time. If you are taking lot of time, it basically means actual time is greater than critical time. In other words, actual time is greater than 2L by C. Under this condition, we say it is a case of gradual closure. So actual time greater than 2L by C, I am seeing over here, option D is correct. Now velocity of pressure wave in terms of bulk modulus is equal to how much? The value of C basically he is asking. C is equal to very standard formula, root over of bulk modulus divided by rho. So root over of bulk modulus by rho, you can see over here, option C would be the correct answer. Option C over here is the correct answer. The coefficient of friction in terms of shear stress. Now this is not your PYQ, it's a slightly difficult question. It might not be important, but still I will mention it to you. You see, the value of V star we are having, this is called a shear velocity. This V star is equal to, it is equal to root over of tau naught by rho, also V into root over of F by 8. Now F over here is friction factor. If it is coefficient of friction, instead of 8, it is supposed to be 2. It is supposed to be 2. Now if you square on both sides, you are getting tau naught by rho is equal to V square F by 2. The value of F over here becomes equal to how much? 2 times tau naught upon rho into V square. 2 times tau naught upon rho into V square. Option B will be correct. This is not your PYQ. I just took one question from a slightly difficult side just to show you the possible questions. Okay? This is not that important for you. Moving further. This is important. When the pipes are connected in parallel, the total head loss is going to be, just now I mentioned, head loss is going to be same in every pipe. So the answer over here is option B. Discharge is going to be added up, head loss is going to be same. Next thing, L1, L2 and L3 are the length of 3 pipes connected in series. If the diameters are D1, D2 and D3, then the equivalent size of the pipe is given by what? So basically he is assuming friction factor over here is a constant. F is constant. If F is constant, then we use something called as Dupit's equation. Dupit's equation. Now what does Dupit's equation says? It says that L equivalent upon D equivalent power phi is equal to L1 upon D1 power phi plus L2 upon D2 power phi, so on and so forth till Ln upon Dn power phi. In this case only 3 pipes are there. So I can write over here. L by D power phi is equal to L1 by D1 power phi and so on. Option A would be a correct answer over here. Efficiency of power transmission is given by what? In the case of power transmission, the value of efficiency is equal to net head by gross head. It is net head by gross head. Net head is equal to gross head minus head loss. Gross head is equal to capital H. So capital H minus head loss divided by capital H. Option A would be correct over here. Option A would be correct. Diameter of the nozzle for maximum power transmission is given by. For maximum power transmission, the value of diameter of nozzle is equal to 5th root of 2 times FL upon, D power phi upon 2 times FL. It is d power phi fourth root of d power phi upon 2 times FL. But you see, he is using over here F as coefficient of friction. If he uses F as coefficient of friction, I'll take 8 over here. So it is equal to fourth root of capital D power phi upon 8 times FL. The correct answer is option D over here. When does water hammer take place? Water hammer takes place when the fluid is flowing with high velocity, when the fluid is flowing with high pressure. Fluid is suddenly brought to rest by closing the valve. Option C is the best answer over here. For water hammer to take place, you are supposed to block the flow basically. Okay. What is the equation of shear stress? Sometime back I mentioned to you, the value of tau is equal to minus of dP by dx multiplied to R by 2. So option C would be correct over here. So these were the questions which were relevant to your examination, and some of them were your PYQs in RRB JE examination. I hope this session was fruitful to you, and again I am apologizing for the 2-3 minutes of disturbance that happened in between. Thank you, all the best to all of you.